What if I told you that you are currently moving faster than a speeding bullet, even while sitting completely still? The ground beneath you is tearing through space at over 1,000 miles per hour. The planet spins, the solar system races around the sun, the galaxy rotates, and you are along for every single one of these rides whether you feel them or not. But why? Why does everything in the universe spin? This is not a random coincidence. There is a hidden, invisible principle behind every rotation in the cosmos. From a basketball balanced on your fingertip to a supermassive black hole bending spacetime at the center of a galaxy, we live in a universe shaped by motion, rotation, collapse, and collision. And once you see the thread that connects all of it, you will never look at the night sky the same way again. The answer begins with one of the most powerful laws in physics: angular momentum. Imagine a pool ball rolling across a table. It has linear momentum, a straight line motion that keeps it moving until friction or a collision changes its path. Now imagine that same ball, but instead of pushing it forward, you spin it. That spin creates angular momentum. And here is the crucial part. In a closed system, angular momentum is conserved. It cannot simply vanish. It can be transferred. It can be redistributed. It can be changed by an outside torque. But without an external influence, once something starts spinning, that rotation tends to continue. This principle is as fundamental to the universe as gravity itself. But the real magic happens when spinning objects change size. Think of a figure skater pulling in her arms during a spin. She speeds up dramatically, not because she pushes harder, but because her mass moves closer to her axis of rotation. Her angular momentum stays nearly constant, so her rotation speed must increase to compensate. The same conservation principle that spins a skater also helps explain why collapsing cosmic structures rotate. It helps shape tornadoes, stars, planets, neutron stars, and even the matter swirling around black holes. The universe runs on this principle. Now let us see where it takes us. 4.5 billion years ago, our solar system was nothing but a vast, slowly rotating cloud of gas and dust. A nebula drifting through space, spanning light years across. Over millions of years, gravity pulled that cloud inward. As it collapsed, it spun faster and faster. The same principle as the figure skater, scaled to cosmic proportions. The center became dense and hot enough to ignite into our sun. The remaining material flattened into a spinning disk, a protoplanetary disk, and from that swirling debris, the planets formed. All 8 major planets still orbit the sun in roughly the same direction. Each one still carries part of the angular momentum of that original ancient cloud. Mercury, the innermost planet, whips around the sun in just 88 days at over 100,000 miles per hour. Neptune, at the far edge, takes 165 years to complete a single orbit. Same disk, same origin, different distances, different speeds. But there is something deeply strange about how the planets themselves rotate. They do not all spin the same way. Earth rotates counterclockwise, completing one full turn every 24 hours. Mars, our neighbor, spins at almost the same speed. A Martian day is just around 40 minutes longer than ours. But Venus spins backwards, clockwise, and painfully slow. A single day on Venus lasts longer than its year. It takes about 243 Earth days to complete one rotation. The sun rises in the west and sets in the east, with a full sunrise-to-sunrise cycle stretching across months. No one knows exactly why Venus spins the wrong way. One possible explanation is a massive ancient impact. Other ideas involve tidal effects from the sun, atmospheric forces, and long-term gravitational interactions. Whatever the cause, Venus is proof that the solar system was not built gently. It was shaped by chaos. Uranus is even stranger. It spins on its side, tilted about 97 degrees relative to its orbit. While most planets behave like spinning tops, Uranus rolls around the sun like a ball. Its poles can face the sun directly, giving each hemisphere decades of continuous daylight followed by decades of darkness. A massive ancient collision may have knocked Uranus onto its side, though the exact story is still debated. Another world. Another violent mystery. Jupiter, the king of the planets, spins so fast that its equator bulges outward. One Jupiter day lasts just under 10 hours, even though the planet is 11 times wider than Earth. The centrifugal force from that spin stretches the gas giant visibly. Saturn, with its rings, spins almost as fast. And deep inside both of these worlds, rotation helps generate enormous magnetic fields. These fields trap deadly radiation belts and create some of the harshest environments in the solar system. This brings us to a mind-blowing realization. Earth's 24-hour day was not created in isolation. It was shaped by violence, gravity, and time. When Earth was still young, a Mars-sized body called Theia slammed into it with unimaginable force. Not a gentle nudge, not a slow collision. A cataclysmic impact that likely liquefied huge parts of both worlds and hurled a spray of molten rock into orbit. That debris eventually coalesced into our moon. The impact helped shape Earth's rotation and tilted our planet, but the familiar 24-hour day we know today is also the result of billions of years of tidal breaking caused by the moon. Early Earth likely spun much faster. Over time, the moon's gravity pulled on Earth's oceans and crust, gradually slowing the planet's rotation. So our clocks, our calendars, our tides, and our entire rhythm of day and night are connected to an ancient cosmic collision and the slow gravitational pull that followed. If Theia had hit at a different angle, Earth might have spun differently. If it had missed entirely, we might have no moon and far weaker tides. Our days might be shorter, our planet might be less stable. The world we know could have been completely different. Every sunrise you have ever seen is connected to a catastrophe that happened over 4 billion years ago. But Earth is not the only thing spinning in our neighborhood. The sun rotates too. Not as a solid body like Earth, but as a sphere of superheated plasma, where the equator spins faster than the poles. The equator completes a full rotation in about 25 days. The poles take roughly 35. This differential rotation twists and tangles the sun's magnetic field lines until they become unstable. When they snap and reconnect, they release colossal bursts of energy. Solar flares, coronal mass ejections, billion-ton clouds of plasma can be hurled into space, traveling at millions of miles per hour. Some of those eruptions have struck Earth. The most famous geomagnetic storm on record, the Carrington event of 1859, caused sparks in telegraph systems, shocked operators, disrupted communications, and produced auroras so bright that people in some regions could read newspapers by their light. If a Carrington-level event hit our modern technological world directly, it could damage satellites, disrupt power grids, interrupt navigation systems, and cause enormous economic damage. The sun's spin does not just help make it active, it helps make it dangerous. Pull back further. Our entire Milky Way galaxy rotates once every roughly 230 million years. The last time Earth was in a similar position around the galaxy, dinosaurs were beginning to dominate the planet. Pause on that. 230 million years for a single rotation. And yet the galaxy spins so smoothly, so silently, that no human being has ever directly felt its motion. We are carried through space at over 500,000 miles per hour, and every instinct you have tells you that you are standing perfectly still. But there is something deeply strange about how galaxies spin. When astronomers measured the rotation speeds of galaxies, the numbers did not add up. The outer regions were moving far faster than expected. According to the gravity of the visible stars and gas alone, stars near the edge of a galaxy should orbit more slowly than stars closer to the center, just as Neptune orbits the Sun more slowly than Mercury. But many galaxies do not behave that way. Their outer stars keep moving at unexpectedly high speeds. It was as if an invisible hand was helping hold the galaxy together. The leading explanation is mass we cannot see, something invisible, something enormous, something spread throughout and beyond galaxies in giant halos, providing the extra gravitational pull needed to keep stars from flying away. Dark matter, an invisible substance that appears to make up a large fraction of the universe's matter, revealing itself not through light, but through gravity. We discovered some of the strongest evidence for dark matter not by seeing it directly, but by watching how galaxies spin. The rotation of galaxies became one of the clues that changed our understanding of the universe. And now we arrive at the most extreme rotators in the known cosmos, black holes. When a massive star dies, its core can collapse under its own gravity. If the remaining mass is great enough, not even neutron pressure can stop the collapse. A black hole is born, but the star was spinning before it died. And as the core collapses, that spin can become extreme, just like the figure skater pulling in her arms. Except this time, the skater is a stellar core collapsing from thousands of miles across into an object whose gravity is so intense that not even light can escape. Some black holes may spin close to the maximum allowed by physics. In systems such as GRS 1915+05, measurements suggest an extremely high spin. And when a black hole spins, it does something almost impossible to imagine. It drags spacetime around with it. This phenomenon is called frame dragging. The fabric of the universe itself is twisted by rotation. Space and time swirl around the black hole like water around a drain, and anything that falls too close is pulled not only by gravity, but by the spinning geometry of reality itself. Beyond black holes there are pulsars, rapidly spinning cores of dead stars, remnants of supernovae, crushed into neutron stars no larger than a city. Some pulsars spin hundreds of times per second. Their magnetic poles fire beams of radiation across space like lighthouse beacons. Every time one of those beams sweeps past Earth, we detect a pulse. These pulses are so precise, so perfectly regular, that when they were first discovered, astronomers briefly considered the possibility that they might be signals from an alien civilization. The universe's fastest rotators once looked like a message from intelligent life. Everything spins. The planets, the stars, the galaxies, the black holes, the pulsars. And the reason traces back to the way structure formed in the early universe. The Big Bang did not leave behind a perfectly smooth cosmos. It left tiny fluctuations, imperceptible differences in density, seated in the newborn universe and stretched across space as the universe expanded. Over time, those tiny differences became regions where gravity could take hold. Matter flowed toward denser regions. Gas gathered. Clouds collapsed, stars ignited, galaxies formed, and as matter fell inward, it did not fall perfectly straight. Neighboring regions tugged on each other. Gravity twisted the motion. Small asymmetries became rotation. Those early density differences became the seeds of cosmic structure. The spin we see today is not a single frozen wheel from the Big Bang itself, but the result of gravity, collapse, collision, and angular momentum conservation working together for 13.8 billion years. Every planet rotating, every star spinning, every galaxy turning, every black hole dragging spacetime into its vortex. All of it is connected by the same principle: motion preserved, reshaped, transferred, and amplified across cosmic time. What we are watching, every time we look at a spinning planet or a rotating galaxy, is not random motion. It is the universe remembering how it formed. The rotation never stopped. It only changed form. So the next time you stand still, remember this. You are not still. You are spinning with a planet at over 1,000 miles per hour, orbiting the sun at about 67,000 miles per hour, and rotating with the Milky Way at over 500,000 miles per hour. All of it connected by a single invisible principle that has been active since the first structures began to form. You are riding through space on a spinning planet, inside a spinning solar system, inside a spinning galaxy. And the motion is not finished with you yet. Subscribe to Cosmos and hit the bell so you never miss what we uncover next. And if you want to keep going, watch the next video on your screen now. And grab your free guidebook from the description below.